Hello, and welcome to Session 2, Understanding Networking Principles and Their Protocols. In this session, we'll explore how networks form the backbone of modern computing and cloud systems. Networking enables communication and data exchange between devices, applications, and services across the world, making it the foundation of today's digital landscape. By understanding the key networking principles and protocols, you'll gain insight into how cloud environments operate, how information travels securely and efficiently, how systems stay connected, and how large-scale computing infrastructures are made possible. Together, we'll uncover how networking supports the seamless integration, scalability, and performance that define modern technology and cloud computing. Networking allows devices to share resources and data efficiently. It connects clients to remote servers and cloud computing. Networks can be local or span wide areas. They ensure secure and quick information transfer. Virtual networks create secure connections over public networks. Topology defines a network's layout. Bandwidth and latency affect data transmission efficiency. IP addresses identify devices on a network. Routers and switches control data flow. Firewalls ensure network security against unauthorized access. This is a main call out for this scene. It brings into focus the core idea being discussed. The OSI model has 7 layers for communication aspects. The TCP/IP model is practical with 4 layers. These models ensure system interoperability. Protocols are rules for network device communication. TCP/IP is the Internet's backbone, ensuring data reliability. Protocols govern data formatting and transmission. TCP/IP ensures reliable data delivery. HTTP/HTTPS are for web communication, with HTTPS adding security. FTP/SITP transfer files securely. DNS translates domain names into IP addresses. Cloud networking involves virtual networks and load balancers. Providers like AWS manage these networks for security. Network segmentation and VPNs maintain privacy. Firewalls protect cloud systems. Scalability and high availability are cloud network goals. Standards ensure devices communicate effectively. IEEE and ISO develop networking standards. TCP/IP and HTTP are maintained by IETF. Standards ensure compatibility and security in networks. They enable global connectivity and cloud computing. Topology affects data flow and network expansion. Bus topology connects all devices to a single cable. Star topology uses a central hub for connections. Ring topology forms a circular data path. Mesh topology connects devices directly to each other. Bus topology connects devices to a central cable. It's simple and low cost for small networks. A cable failure affects the entire network. Data collisions increase with more devices. Suitable for temporary networks, not modern businesses. Star topology connects devices to a central hub. It's easy to manage and troubleshoot. A hub failure affects the entire network. Common in office and wireless networks, it's widely used in modern LANs for reliability. Ring topology connects devices in a circle. Data travels in one direction, reducing collisions. Mesh topology connects each device directly. It offers high reliability and fault tolerance. Mesh is ideal for critical systems needing uptime. Hybrid topology combines different topologies. Tree topology links star networks to a backbone. They're scalable and support complex networks. Higher installation and maintenance costs are a drawback. Best for large organizations needing hierarchical management. Network standards ensure reliable communication. They define data transmission rules and formats. Compatibility between devices is a key benefit. Standards drive innovation and market growth. Security protocols protect data and user privacy. Interoperability allows devices from different vendors to connect. IEEE 802.3 standardizes Ethernet connections. IEEE 802.11 defines Wi-Fi standards. Compatibility drives global connectivity. It reduces costs and promotes collaboration. Standards evolve for higher speeds and lower latency. Ethernet speeds have increased significantly. Wi-Fi standards now offer high performance. Standardization ensures backward compatibility. It enables technologies like cloud computing and real-time collaboration. Standards provide a stable foundation for new tech. Developers can create globally functioning applications. IoT and 5G rely on open networking standards. Universal standards promote competition. They improve quality and reduce costs. Modern standards integrate security protocols. HTTPS ensures secure web communication. DOPA3 enhances Wi-Fi security. Standards help comply with regulations like GDPR. They protect against data breaches and unauthorized access. Intranet hardware includes servers, switches, and routers. Servers manage and deliver data within the network. Switches connect multiple devices in LAN. Routers link the intranet to external networks. Firewalls protect against unauthorized access. Network software manages communication and security. Operating systems control access to resources. Management software monitors network performance. Web servers host intranet websites. Security software protects against threats. Session summary and closing. In this session, we learned that networking principles and protocols are fundamental to modern computing. They enable secure, efficient communication between systems and devices, while standards and network topologies ensure reliability and consistency in design. A solid understanding of these concepts is essential for building robust networks that support both cloud and enterprise environments. Thank you for your attention today. If you have any questions, please feel free to contact us via WhatsApp at 07000 484 361,688. Thank you and see you soon.